Yes. Well, I'm almost back. Almost. Okay. Hello. This looks very difficult, but it is not. It's not that difficult. In fact, I'm now here. I have to use this monitor. So these are the, this is that formula. You can express stuff in previous stuff. Hey, how Emmanuel and David, how are you? I wish I could show the formulas to you. Well, maybe I can. Just put it on one. Not sure if that works. Oh, it should work. Up, down. It's probably still not readable anyway. There we go. I so hope I didn't make a mistake here. G7 is going to be this. So I have here each HN. No, okay, I'll show you what I have. So we're trying to calculate the Taylor series of the square root of a fourth degree polynomial, which you can write as the sum over from n is 0 to infinity of some function hn to the power u to the power hn times u to the power n. But then, as you can see, I mean here, if you can see it, it's like really small font. But okay, here we have a u, and then here we have a u squared, and here we have u to the power 3, u to the power 4, u to the power 5. So this whole thing is h5, and this whole thing is h4, and so on. And you see that you have here 1/3 times the square root of d0, 1/4 times the square root of d0, 1/5 times the square root of d0, 1/6 times the square root of d0, and so on. And yeah, you probably understand that this is not all. We can continue and 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 continue. Okay, I won't scroll down. But it's kind of a pattern. So I'm saying here, you know, we might as well use gn, where then gn is actually, well, it was for n larger than 0, we can write hn is 1 divided by n times the square root of d0 times some other function. And now the other function is, for example, what is between these enormous brackets? This would be g6. Yeah, because the 1/6 times square root of d0 is already falsified. And I already did g6, so instead of this huge formula, I'm having this, where I just refer back to g3, g4, and g5. So now I'm here at g7. So g7 is this thing, and if the pattern works out, it's going to be something simple times G something for the first term. So I'm gonna guess there's definitely a minus there, and then a D4. Where's my D4? I have to copy it because I don't want to. No D4. Okay, D4. Of course, there's a D4. Where's my D4? Oh, here. Divided by 3D0. That's the first time I see a 3 there. Well, not really. I already have divided by 6 here. That's also contains a 3. Times this thing here between brackets. Well, that looks very much like this thing here, which is G3. So far so good. And then we get the next one. Five, 8. The 11 12th is something that seems to be always n minus 1 divided by n. Or else not the n, but it's an integer. And here we have 4 divided by 5. And now for the first time I'm looking at something that is 5 divided by 8. What the F? Let me make some tea. Oh well. Hopefully we can guess what that is. Of course we can guess it. It's just more effort. I'll just type it in. Okay, minus 5 times D3 divided by 8 D0. That's always D0 at least. We only divide by D0. And then times this thing here. And that thing is this, right? Sure. Exactly. So that's G4. G4. Plop. And that would be that term. Now we get the next term. Again a minus. And then 4D2. 4D2 divided by 5D0 times, well, that is 4D2 divided by 5D0 times this thing. And that whole thing then, well, that I see the pattern. That's going to be G5. What a girl, let's see if we can find that back. It would be this thing, yeah. So if I squint my eyes, no, I just look at the 4, 3, 2, 8. 4, 3, 2, 8. Yeah, no, that's, yeah, absolutely the same thing. No, it's the same thing. G5. And this is a minus sign again. Lots of minus signs there. And then we get 11 times d1 divided by 12 times d0. Times, well, g6. I'm not even going to look anymore. This whole thing must be g6. Okay, I'll look one more time. Yep, it's the same. I'm just kidding. Yeah, but it is the same. So g6. Remind you, I have no idea, man. I have no idea. First, it didn't even want to render it. Can't render this. It will slow down your browser. And then you have to click render it anyway. It did not slow down my browser. G8. Uh-oh. Subscript 8. No. Con 8. Subscript 8 is. At some point the complete pattern must be obvious, hopefully. I think I just did this one. Now we need a thing that is has u to the power 8, which is no, you don't, yeah, here it is. Holy mother, u to the power 8. So this whole thing is, and this, and that. Yep, so it is 1/8 times the square root of d0, and then we get a minus. It's more minus than anything else. It's only minus. Well, that's not true. There's a few pluses here, but if this pattern continues, d4 divided by 2d0. Times I think g4, just twice the same thing, and then that's why the number of terms grow. So it would make sense now, wouldn't it? Okay, is this g4? I can hardly remember that. So let's say the 2461 ish. 2? Yeah. 2461, so it's this one, which is g4. Thank God. No, that must be g4. Minus. Now it's 7/10. 73 divided by 10d0. Times this whole thing. And that is probably the next one then, right? So g5. What else can it be? I'm literally not even going to look anymore. I think I believe that part of the pattern now. Although it would probably be safer if I, you know, had 5, 5, 6, or at the very least. Maybe I should check it. But what else can it be? It's like, really. Okay. It's G5. And then we get... what the hell? Oh, the minus is all the way down here. I think there is no minus or plus here. Yeah. What do you think? Little formula? No, 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 no. This is the minus. And then we get 5 times G2 divided by 6 times D0 times, yeah, and that this is so big that must be G6. I mean, the next one is G7, so D2 divided by, yep, okay, and then we get again a minus, I bet, yep, this minus here, minus 13 D1 divided by 14 D0 times G7. Right, so in the beginning we have some weird hiccups, but it's probably because we have a D0, 1, 2, 3, and 4. And in the beginning there's no D4. Here it comes to D4 the first time. And then we can completely express it in the previous ones. So this uses G3 all the way back. G4 and G5. This uses G2, G3 and G4. So you kind of expect that to be enough, but yeah, there's some other term here. But okay. Hopefully after this it's really just a repeat of something we can guess. I'm gonna do G9. G9, that one times u to the power 8, so this is 9, this is 9, so 1/9 times the square root of D0 times G9, which is then again a minus sign, minus 3D4 divided by 5D0. Times, yeah, probably G4. Now look at it again, 4, 3, 2, 8. 4, 3, 2, 8. So that's G5. What the hell? So G5. There goes my pattern. Yep, well, it's G5. And then minus 3 times D3. D3 just D3 divided by 4 times D0. Times, well, that really has to be G6. Otherwise, I mean, this was 5, so now we get 6. No way, this is also G5. or the G6 is not there. Yeah, look at it. Look at it. So this is 2, 4, 10, and with 1, 2, 3, 4, 5 divisions. It's already here, same thing. 2, 4, 10 with 1, 2, 3, 4, 5 divisions. So this is 1 and that is 6. G6, okay. At least that makes still sense then. I bet now we get G7. We're working on D9, so that would be this one. Then dip, that's the next one. 62. 6D2 divided by 7D0 times. Yeah, it's gonna be G7, man. Come on. Of course it is. D7. That's a big thing. Oh no, it's not. This is G7. 3, 4, 5. I'm gonna have a look at it after all anyway. 3, 8, 5 with 1, 2, 3, 4, 5 divisions. Wait a minute. No. This phrase is not ending there. We have to include this one as well. So it's more like the 3, 8, 5, 12. With the 1, 2, 3, 4, 5, 6 divisions. 3, 8, 5, 12. That would be this one, which is 7. You need to have a lot of patience. That, yeah. I'm just crazy. But hey, the satisfaction that you get. Now the idea is that my feeling is that I have absolutely no idea if this is going anywhere. But I do it anyway. And then if it goes anywhere, Yeah, it makes me, it reminds me a little bit of my, what's it called? When I graduated from the university. It's the first time. Then I did stuff that was completely exhausting and gave me the feeling that I was stuck. So I was like really walking in the dark with no way if the next step would be a fall to death or that I would stumble into a wall or whatever, but I continued anyway. And then, fuck yeah, I reached the next milestone. And that several times. I have never ever done anything that difficult. The thing that existed really of multiple times that I was, this is my limit. It was also something mathematical. And then afterwards, during the, what do you call that? Bespreking in English. The guy that had studied this was a mathematician, I guess, but he said, you surely gave me a hard time. I don't know how much time he did spend into it, checking my stuff, but I was secretly surprised that he managed to check it at all. So yeah, it's beyond my horizon, but we're still stumbling. So who knows where we'll get, huh? Okay, that's what G7, and the next one is, I'm completely lost it, of course. This is G9, so I need a 1/9. Get that past that point here. This is the 3D4 term, and then we get a 3D3 term, and then we get a 6D2 term, and then we get this term minus 15 D1 divided by, of course, 16, it's one more than 15, D0, yeah, like always. By now, that's kind of clear what this is, the last term. It's not that clear though. It's like, oh no, actually it is. 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5. 4, 3, even. Maybe I should put these things in the same column. Put the D2 behind it. Space. And then the last term. Let's put the last terms all in the same column. Poor Gemini, it will not understand all those spaces. Can't even line it up. definitely need a mono font here, but yeah, can't switch to that, I'm afraid. What would come before this is something times G1. And well, we just know that it's negative, so it must be this one. And that is D1 divided by 2D0. And that's exactly it. How cool is that? So minus, so we have 6, 5, 4, 3, and now we get 2, 1. You can even write it. D1 divided by 2D0 times G1. Because then we get the D1 squared, that's this one, divided by 4D0 squared. But still plus that thingy at the end. Yeah. This is kind of a... Yeah, let's not look at the first terms. They are confusing. And this seems to be a pattern as well, 4, 5, and then 5, 6, and then 6, 7. And yeah, here no. It's probably 9, 12 here. Yeah, totally. Make this 9, and it's also times 3, it's 12. But I'm afraid I still have to do a lot of terms before I'm really certain. Still looks totally messy. Now this must be a 4. 3, 4, 5. I mean, if there's a 5 here and a 3 here, dude. Okay, that is clear as well then, actually. That's a 4, and then we have to add a 2 here. So this is 1, 2, 3, and 3, 4, 5. Pretty cool. So maybe the reason that it is going a bit weird, like we go from G2, G2, G3, G3, and then suddenly G4, G5. If you go backwards like this, that makes sense, as in 3, 2, 1, 0. Ha ha ha. So we can make up a term here that is 0 times G2 at this point. And then we can shift this one up to the next term. That really belongs to that one then. So this would be 3/4 comes before that. Nope, that's this one. Dang. But this one is G4. G4. No, but this belongs to that one. 6543. 7654. 7654. Well, that one belongs there. And I would really, really like it to move this one up here. But I don't see the pattern in that case. I thought it was just +2. And here also +2. Hopefully I did not make a mistake. But I'm going to shift it anyway, because it seems the most logical thing to do, even though it doesn't really match pattern yet. And then this, yeah, this is just 0. 0 times G2. Well, at least that makes sense. But if you don't even go one further back, then yeah, no, I don't know. I don't know what's happening here. Well, I do. This is I was mistaken here. I should have left that to 2 and 3. If I did change it at all, because that definitely still belongs in this row. I'm an idiot. Yeah, 3, 6. It's right there. Times 3. 3, 5, 7, 9, 6, 8, 10, 12. Completely right. And the one that comes before that then is 1 and 4, which is there. So this one is that term also. Let's move that up. This one back. Yeah, and then there is not anything before that really. Because, well, that would be -1. This would be 2. But, yeah. Maybe we write this one out that it actually is part again. G2 is something times G1. But who cares? Let's continue. This case could be that it's just staying at 4 terms. It never gets more than 4 terms. This is increasing, so it's not going to be 0 anymore. Same, same, same. And extremely predictable. I think the pattern is already complete. Let's do 1 or 2 more just to see if it indeed continues like this. So the next is G10. What am I doing? G10. I have to go. No, this one. Oh, 10 is just 1, 0. I have that. Where's the 1 if you need it? Oh, here. 1, 0 is. Now we can predict it. Shall I predict it and then look if it's correct? No, let me look here. Right, so this is the 16 here, and you go down to the beginning. Nobody knows what's happening here. Oh, this is the U9, so now we get U10, 1/10 square root of D0 times I'm gonna multiply this with 2, so we get 4 times D4. And there is a minus here, which is a pixel between the minus and the division. Minus 4 D4 divided by, and then this one also times 2, so that is 6 times D0 times this whole thing, and that is, yeah, G6. What else can it be? I need another window so I can scroll at the same time. To look at this and look at the other at the same time. Or we can just do the same trick. 2, 4, 10 with 1, 2, 3, 4, 5 divisions. This one. 2, 3, 4, 5. That's 6. Yep. Mm-hmm. 10. And then we get minus 11. Let's do more than that. D3, obviously. Divided. Oh. D. Divided by 14 D0. Times, well, it gets bigger and bigger, so I'm going to call this G7. I really don't want to look at him anymore. And then the next one is, let's see, this is all that one. Then we get 7 minus 7 D2 divided by, yes, scroll to see it, 8 D0 times, like I said, this is just 8 G8. And then we get, of course, minus 17, I bet. Yep, 17. 17 divided by 18. That's the 18. 17 D1 divided by 18 D0 times G9 and so on. Yeah, I'm happy. Etc. No, I didn't ask a question, but let's hit return. See what Gemini thinks of this brilliancy. It always want to calculate stuff with actual numbers instead of just being satisfied with the symbols. Or wants to. I mean, it ends with a paragraph asking for that. Yeah, so the next step is that I want to integrate this. Yeah, I don't have to guess anymore. So normally it's like the Taylor series is like da 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 da, and then it ends, and then something to the order. There's no order here anymore. This is infinitely exact. You just continue till infinity, and then that's it. So we can do an exact. I mean, the dot 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 here is exact in my eyes. We can do an exact integration of this now, which is kind of surprising. I mean, they told me that there was no analytic solution for the integral of the square root of a fourth power polynomial, but okay, still just an infinite series, I guess. But then I just need to evaluate it at 0 and 1. I have a feeling that that is possible. Maybe you should test this first, just in case it contains errors. It's a better feeling if you can call this a milestone that is just correct. Let me see. 10 should be enough for drawing it. In fact, I probably won't even see if this is correct, but they're all the same anyway. So what happens if I calculate all the g's? Then I can calculate the polynomial, and then we have the value of yeah. Oh, that would be the square root of that thing, yeah. so we can compare it at least. I can subtract it. Then we do see the difference, small deviations. Yeah, actually this is exactly the curve that I already draw at the top. That is a square root. Of course. No, yeah. Well, this is just the wavy thing. This whole thing. So let's try this. Yep. I'm gonna copy this. What the hell? I did not ask to do that. I just want to copy it. Copy. And let me go here. Let me think. Here I'm calculating the D values. Right. Let me show you. So, plop. Here you see this curve. Now it's orange because I'm drawing something over it, and it's the same curve. So yeah, just exactly on top of the other curve. So, yeah, no matter what. So I'm drawing this polynomial with coefficients C. So I have the matrix coefficients of my cubic Bezier curve, and then I calculate the coefficients of the polynomial. This is then the polynomial. We draw that one. Then I calculate other coefficients. New polynomial. This time it runs from -1/2 to 1/2. The reason is that then of the full range, the variable of the polynomial is never larger than 1/2. So if we go to the 10th power, then it's already 1/2 to the power 10. So the Taylor series really works. Yeah, this is correct because it draws it on top of each other. So now we're going to do the next one, which is even heftier, I would say. So I want to have now let's make it a vector even instead of an array. Double of G, and then we start with D0. Let me calculate the square root of D0. Call it the square root of D0. And then G0 is, well, I don't have, if you don't have a G0, we have an H0. Well, I have to add that afterwards, I think. Can multiply it with that. The 1/n has to be inside of it. Could do the square root as well. Let's just calculate this sum and then multiply it by that and then add G0. So the first one is actually G1 then. This sum starts at n is 1. We don't have a G0. Yeah, I'm still going to push it back. So we start at G1. G1 is this. D1 divided by 2 times d0. And then the next one, maybe you should paste what I just copied here, so that's way easier to write code. How many? 3? That was the square root of d0. And now it's refusing to. Okay, good enough. The square root of d0 is. What did we say? Yeah, this word, square root of d0 times square root of d0 divided by n times gn. Yeah. Any other structure there? D3 and there's no. Wait a minute, yeah. Actually, I think I see it. This one. Third place. So we would expect another D3, but then every time -2. So this now becomes a -1. So plus D3 divided by and then here at every time -2. So we expect plus D3 divided by D0. But we have this. Oh, times G1, sorry. Times G1. Yep, but we have this, but that is the same thing, I think. Because if I remove the D, it's a plus. It's a plus. I remove the D3. I remove 2D2. And that is equal to G1. So these two are the same thing. This is a beautiful way of doing mathematics. It's just every real mathematician get nausea, but it just worked, man. Pattern recognition. So same thing here, I guess. D2. Yeah, see, we have a D2 here. We need something with a D2 and a D2. Well, that should be this one. So let's begin with filling it in. We expect 4, 3, 2, 1. So we expect 1 D2 divided by that. I lost my cursor. Times 2 D0 times G2. That's what we expect because of this table here. And what we have is exactly that. Yeah, just the same thing. Beautiful. Now let's see if we can attach even more to that. Maybe this extra term actually belongs here. Because also plus, this one also went negative. Well, positive, I mean. So this is shift this one up. Shift everything else. One up. Make this in 1. And then here we get 0 times D4 divided by 2D0 times G2. So that would mean that if I go even further back, then we would expect a plus 1 times d4 divided by 1 times d0 times d1. And that is of course equal to this. How beautiful. We have the d4, we have the divide by d1, d0 I mean, and then we have a d1 divided by 2d0, which is g1. Yep. Now, then I guess that this one is going to reveal what d0 is. We don't have a d0, but now I can deduce it. Because this term, whatever d0 is has to be whatever makes that. This one drops out because it becomes also a 0 here. But then I still need two terms, one for this one and one for this one. Maybe those two combined give me that. This is a d3, so it probably belongs here. It totally belongs here. So what g0 would be 1. Let me figure that out. So this one is going to be plus 2 times d4 divided by 0. Oh, that's actually correct. Yeah, d0 does not exist because it is a division by d0. It's infinity. So it does actually work out. Cool. But not really useful. But yeah, it's divided by 0. Oh, yeah, I'm just filling it in for fun. Times g0. And that should be this. So g0 must be infinity. And cancel the division by 0. Okay, no problem. Yeah, well, okay, this is a bit too unmathematical, so I'm going to remove the 0 and remove the g0. They cancel. And then we just have 2d4 divided by that. So, zip. And then we have a G minus 1. Yeah, no, it gets too weird now. T3 belongs here though. Yep, so again the same thing. Might as well fill it in then. Right. Replace plus 3. Just, you know, this 3 here, but then negative. Divided by, and then here we get 0 d0. Wait, it belongs there. So 0 times d0. But we don't divide by 0 because next we must multiply by g0, which cancels the division by 0. And then it's the same thing as this. Wait a minute. Or is it 2 missing there? That doesn't fit then. Did I make a mistake then? This might be wrong. If I notice this mistake, because a division by 0 is cancelled by a multiplication by d0, that would be fun. But okay, we have other terms here, although this is d2. It's nothing to do with d2, this thing. This is 0 times d2 divided by d0 times d1. So that one is also alive. 0 times this is 1 times. This is 0 times 1 G1. You could set G minus 1 to 0, then this is also 0. Yeah, let's check this one again. G3. G3 is just this. It's totally 3d3 divided by 2d0. Yeah. No mistake there. I think this is correct. G2. Oh well, if you divide by 0, you can get anything, right? 0. I'll leave it here, but logical, it's not logical in my eyes. Right, okay, I might as well erase this. So, and then this is again D2, so it belongs here, and it's a plus. So it's just plus 1 times D2 divided by 1. D0. Okay, what happened? Oh, that all belongs here? I don't know. Wait. The minus sign is the first one, and now it's no longer the first one. Now I might as well fill a 1 in here then. If we go from the 2 to 2 here, it makes no sense, and I go from 1 to 1. D0 just doesn't exist. This doesn't exist, also 1, 1. And then here you would expect to go to from 2 to 2. And the D0 is gone. But this goes to plus D1. Which is this? It all works out. How amazing. Plus 1 times that. Yeah. Now we have the full pattern. Not write code for it. It's probably just the easiest to push these first things and then only start a loop once we have something that makes sense. Yeah, at least no D0s. I guess you can start here in the loop and push the rest manually. Yeah, I think we should get rid of the division by D0 because everything is divided by D0. How do I get rid of that? Well, replace It's not that easy, is it? I would make d1 equal to d1, a half times d1, not dividing by d0. Then the new d1 is d0 times its large, which means that this one is d0 times its large, which means I still have to divide by d0 here for the d2. It's not really possible to get rid of it because of the recursion. Nope. In the end we have to divide by d0 a lot. Like by this time you have divided by d0 like 10 times. Can't get rid of it. Okay. But we have variables d4, d3, d2 and d1 all divided by d0. What is the special case about this d0? Why would that not be 0? Nobody knows. Let's say d0 is the constant factor of the polynomial in U, which means that it is equal to the value, whatever value that is, halfway the Bezier curve. At t is a half. What value is that? It's the velocity, isn't it? Yeah, the velocity can never be 0, I think. So also not at t is a half. Therefore, d0 is not a half. It's not 0. Okay, let's calculate d1 divided by d0. No, it's not like that. Let's call it, let's, I don't know, add an underscore or something. That's this one. Then we push back the next one, which is this, that is d2 underscore minus d0. That's really suckage. I wanted to call it a d1, so let's just push something to it already. Make it give it a size 1. Don't know it's G1. But coincidentally, also G1. What? Yeah. I'll be nice. So that will be this one, and then we got the next one. G3, G dot push back. .5 times T3 minus 0 then 3/4 T1 times G2. And then we get this 2.0 times D4 plus 0.5 times D3 times G1 minus 0.5 times D2 times, well, yeah, I lost where it was, man. A half times minus a half times T2. What's T2? Minus 5/6 times D1 times G3. And then we can make a loop. I guess it doesn't really matter. I'm just gonna start at 0. Yeah, I don't know. pushback. This, the next was 1, 2, 3, 4, 5 has I as 0. So that is 1 minus I. Times d4 times g I plus 1 minus 2I 2 times I plus 1 times d3 divided by 2 times I plus 4 times g I plus 2 and then we get minus I plus 2 times d2 divided by I plus 3 times g I plus 3 minus I that goes per 2 so something what 7 minus 2I times d1 divided by, and it goes up also. Wait a minute, that was wrong. I have the minus here, so this is 2I minus 7. It's not minus 7, it's plus 7. And here we have 2 times I plus 8 times g I plus 4. Oh. Right, so see, the absolute values are correct, I guess, because this must be 1 times d4. I think that looks silly here, so I'm gonna remove it. d1 minus d3 divided by 4, 2d2 divided by 3, and 7/8. Okay, 4, 3, 2, 0, 0, 0, 1, 2, 3, 4. So, yeah. The G runs up in all cases, so this is n with +1, so that must be I plus something so that it fits. +1, +2, +3, +4. This must be G1 if I is 0 till the indexes of G is okay. Then we have a D4, a D3, a D2 and D1. And a +1, a -1, a -2, and a -7 for I is 0. And the division is 8 divided by 3 divided by 4 divided by 1. They're all plus I, except this one. I guess since this is a double, I don't have to make that a double. Just use 1 minus I. So if I grows, then this must go down with 1 step. Yeah, that's okay. And the next one, if I grows, it goes down with 2 steps. And that's not okay, because it grows. I'm dealing with the minus here, man. I should not... Oh, actually, it does grow. Yeah, okay. No, this is... yep. So between parentheses here is the absolute value. So it's 1, 3, 5, etc. That would be that. This one is starting at 2, going up with 1. And divided by 3, going up with 1. And this is 7 going up with 2. And 8 going up with 2. Okay. Should be good. Then we have to make a lobber. Kind of like this one. Function 3. Well, let's copy by reference, because I'm definitely not going to copy that vector. This one also takes u, although it doesn't really matter, I think. Yeah, definitely. Well, I mean, I can call it t, but it's t minus a half, so I'll call that a u. And then I get not this, not that at all. The square root of d0 I don't need that until here. Likewise, you don't need this vector until here. Power of t, yeah, let's make that a u. We begin with 1, so that's u to the power 0. That means that we shouldn't do that, because I'm already having that. You have to start with u itself. And then this u to the power 1 must be multiplied with g. 1. Yeah, but if I run over g like this, we also have to deal with the first element. How annoying is that? Maybe I should push back something to the zeroth place so that it automatically becomes... That's not possible because I have to divide by it. I'm gonna run over them. Of course I'm going to run over I. Way better. And then we must do GI. Divided by I. And anywhere else I used n, so let's use n here. This is my n. But then in the end, we also have to multiply this with the square root of d0. I want to do that at the end. So let's just make this a 0, a 1. And then here I'm going to return the square root of d0 times result. I think that works. So now I have a function f3 that if you pass it a u between 0 and 1, it returns the same as the functions that we have here. So if you plot that, then it should be again exactly the same thing. Proving that all of this is correct. Took only less than 2 hours, no problem. How am I going to plot F3? Well, that is probably... Abhimanyu, good night, man. Sleep well. Yeah, Kotao, hi. I feel caught. K0, no, plot. Oh, plot was already done, I think. Here's the plotting. Copy. Three. And U is still U, so yeah. And now we plot GUF. And I give it a color. I can never choose which color. I always want purple for some reason, but all the other things, they're all light. Why are they so light? I need dark colors. Black, yeah. Magenta, blue. I need way more darker colors. Indigo. I made somewhere else a whole list of darker colors. They are only used for the points. These are all way too light. I gave them names as well though, so I might as well add them to that list, I think. Of course it does not compile, because I forgot to rename that I to N. There's another one here. Oh, that was all. I mean, in terms of the compile errors. Well, I think, I mean, either it's so far off that it's outside my window, or no error. It works. 2 hours of this kind of formulas, analysis, blah, 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 blah. It's hard to believe, right? That it just works. So all we're going to do is, I don't believe it. I made a mistake. I'm sure of it. So let's not plot this one, and also not plot this one. And now we'll probably see nothing instead of that it was on top. Oh, but it was on top. Oh man, I'm so good. No errors. Holy fuck. So this is the Taylor rakes, the Taylor series, the rakes, Jesus Christ. The Taylor series of the square root of the 4th degree polynomial. Expressed as a polynomial of degree, I don't know, what was that, 10? What did we use? 10 degree polynomial. So yeah, absolutely awesome. This is 100% correct, except when it is not. So maybe I should subtract. I mean, it's a Taylor series, so maybe there is something wrong in the end, but that's unlikely, right? Because we just use this. But okay, I'm going to you know, the just in case scenario. Let's subtract f2 from it, which is well, I mean that should be okay. That's definitely okay. Okay, no, let's go back even. F is even more. It will, if f is really canonical, right? I mean, can't get anything that is more likely to be correct than that. So I'm going to subtract f from it, meaning we plot in fact f3 minus f, but f wants to have the t value, so that would be then u plus half also, yeah. And then we also have to capture f. Yeah, and then we have to blow it up, of course, because yeah, this is going to be nothing. Okay, I want to see nothing first. Shocking. What the hell went wrong there? Man, Twilight Zone feeling. This is the one I plot, right? I mean, thank God. So we're plotting this one, and now suddenly when I subtract this, it's not 0. What? This is, I'm not having a happy feeling here. F. Let's plot f as well. I mean, if I plot f and then I subtract f from the other one and plot that, don't tell me they are equal. I want to see two curves at the very least. Why? Okay, this is non-understandable. Nobody gets what is going on here. Does anyone see the stupidity of me? X coordinate is u plus a half, because u runs from minus a half to a half. So x coordinate runs now from 0 to 1. And then we return f3, which is our new, brand new, beautiful, shiny function, minus the thing that if I plot it, it lays exactly on top of it. And then nothing happens. As if this returns 0. Ah, I see it. Okay, this is unfortunately to cry, because I was so happy that it worked. But I'm plotting the fitter too. We didn't plot anything yet. Shit. So, okay. So it can still be completely wrong then. Now I'm going to plot the difference anyway now. It is not okay. Well, in the sense, well, maybe it is semi-okay, but I mean, it's here, right? Down here. You see, it should be 0, but it below and above 0.2 from the end, it's... not accurate at all anymore. Which means I might as well, I guess I did make a mistake. Therefore, in the higher exponent, the higher, exponents. So let's just draw F3. And then they do not lay on top of each other, apparently. Yep. And they have the same color. You gotta be kidding me. Indigo. The other one is default. No. F. Where the hell is F? Here. It is default. Curve line style. I thought it was black or something. I'll make this one orange again. Or again, the other orange is commented out. Yeah, so it's Taylor series around the 1.5. So okay, it makes sense that it is pretty good until it isn't, and that then would be caused by higher exponents, right? Terms with a higher exponent. So I did make a mistake. Well, that sucks. That sucks big time. Because I have no idea how to fix this except for doing everything over again from scratch. Which took 2 hours. Maybe you can do it in 1 hour now, but it's still a lot of work. Of course, if the beginning is okay, so this is okay, this is okay, this is okay. Could be that it's just a bug here, an error that I made here. Still. So if I don't do this at all, I assume that this part is buggy and the rest isn't. Yeah, well, yeah, no, yeah, actually, yes. I mean, nah, yeah, nah. It's also still okay in the middle, right? And then maybe not, well, before it started to deviate from 0.8-ish, well, kind of in the same way, and then here you saw it like dive down. This part is gone. And here it's it was better until here, but then it was diving down like crazy, like there. So the higher orders are gone, but they were also clearly wrong, while this part looks pretty good. I mean, it's not diving down because of the terms that I still have. It must have been diving down because of what I just commented out. So I would say that these are wrong. Then this is wrong. Something is wrong here. What is wrong? Let's hope I see it. Okay, let's say we make this whole why is it? Huh? No. Let's make a G completely empty. That means I should just get the square root of D0. So we have a 1 here, this is empty, and then we return the square root. So yeah, that would be the square root of D0, and then cuts it exactly in the middle at a half. Totally cuts it, right? So that is 100% correct. I wish I could zoom in to it, but if you keep zooming in, zooming in, zooming in, you know, like a Mandelbrot, then it's just going to be exact. Okay. Therefore, that worked. And now I'm going to add one term, namely that term. And now, of course, it still works, because you already saw that, basically. It's going to be a line that is tangent to. So at D is a half, this line is tangent to this thing. Yep, totally, right? I mean, it's not like a factor of 2 off or anything. And if you don't believe it, then well, that's it's tangent to this curve in a half. Absolutely. So that's 100% the correct value. Pretty cool. Of 100% correct value. Right. Can do one more. Now we get a parabola that is fitting the curve there in the middle. Or not, because it's still a straight line. But it is probably because it's, you know, in a saddle point. Yep, now it's called parabola. So if I make it a parabola-ish, then it's fitting like pretty damn good. I think this is, can I make it a parabola? That is the question. I don't know how to. I don't know. I don't know. Oh, wait. 2/3. No. at any rate, yeah, I'm pretty convinced that that one is okay as well. And then the next one. Yeah, no, it must be already very good, actually, immediately, like here. So now it's a third power. So before it was a straight line, and now we have the third power. So yeah. Apparently, that is the best fit here. But yeah. It's not as clear, of course. Maybe I should draw the difference and then see that the result is a power of 4, because yeah, it has to be now. But I don't know how to recognize a power of 4. Plot the logarithm. So it's more and more unclear to see if it is correct, I have to say. But since the first two were okay, maybe I can just manually check this one again, and this also. That's just two things. And then at least we're left with the loop. So I'm pushing back here, G1, G2, and this is G3. G3 is this thing. Yeah. What shall I say about it? So that is 1.5. That is the 3 divided by 2 here. Times D3 divided by D0. That's D3 underscore. Minus 3/4. That is this minus and the 3/4. Times D1 underscore. That is D1 divided by the D0. Times G2. That would be whatever is between the brackets here. Now I'm talking about the last one. Okay, but why not, you know? And this should be G2 because that is this no. Well, this is G2, so can compare it with this, but that's already multiplied by G1 again, which is this. But yeah, okay, so that is D2 divided by D0 and I'm just looking at this, well, just between the brackets here now, because it is used here, right? So the D2 divided by D0, it's the underscore here, is this D2 divided by D0. Yeah. And then we have here minus a half times d1 okay times d1, which is this. So that is a half times a half is a quarter, and d1 times d1, which then is the with the underscore. So that is indeed minus a quarter d1 squared divided by d0 squared. So these three things together is indeed equal to what is between parentheses here. And the d2 itself should be equal to this thing, but not quite, because we have to remove a half square root of d from it. So then the 8 becomes a 4, and we have to divide by the square root of d0 extra, so this becomes d0 to the power 4 2 or d0 squared. So this part comes 4 times d0 squared. And then you can divide that here already out. So then you get 4 times d0 drops out, and you get d2 divided by d0. And here we get minus d1 squared divided by 4 d0 squared. So this was d2 divided by d0, that's this one, minus a half times d1 times g1, which is again a quarter times d1 squared divided by d0 squared, which is what we needed, yeah, here. And that one is definitely right. I mean, you could see that on the graph. So these three are indeed okay. That means that there must be a problem here. Oh wait, there's another pushback. Okay, let's do that one then. So this was 1, 2, 3. So this is G4, which is this. What is between the brackets here? Hello, Osama. Two times d4 divided by d0. That is this. Plus a half times d3 times g1. So the d1 was this, yeah, so half times d1 divided by d0. d1. I lost it. 2 times d4. What's this? Plus a half times d3 times g1, where g1 is a half times d1. I'm not even pronouncing the divided by d0 anymore, if you don't mind. So d1 to 2 times a half, and d1 was also a half. No, yes, half times d1. Yeah, so that's this term here. This minus a half times d2 times g2. That is definitely the same as we had before. The 3d1 times g2. Those are 3/4 d1 times g2. And when you get minus 5/6 times d1 divided by d0 times g3. So that would be that this here is g3, which pretty much looks like it. Totally. Yup. Well, I don't know. I checked it manually again, and this one's also okay. Pretty sure. Yeah, just is. I just checked it. I don't see a problem with it. Which then means that the problem must be in this loop. I'm not going to compare that with the big formula yet. Let's compare it with this. So even if I just add a single one, I mean, it's really wrong, then even a single one should be wrong. So I do that, then I already want to see a serious deviation around 0 and 1. I don't get to see that. What the hell? Yeah. Maybe. I mean, yeah, if you look at it like that, that's pretty serious deviation. But yeah, maybe it is. Yeah, not like this. Doing. That is pretty fast. Yeah. There is, of course, a tiny probability that I just don't go far enough. And we have to just make the loop way bigger. But that would be kind of weird because really it's around a half. So this is 0, the minus half plus a half to the power of 10 is already neglectable and not something like that. The deviation is ridiculous. Yeah, I don't know. I still don't see it. Shit. It's relatively tame now, yeah. It's just there's a deviation around 0, but nothing like that. Nothing like adding even a single, yeah, a 2, yeah, just yeah. Well, not really getting there then. Okay, that this is big. This is a big one, yeah. So apparently, we need. If I stretch a C1 way out, we need a higher. Yeah, more terms for the Taylor series or something. But if you do like this, I mean, the whole thing is just almost a parabola. So pretty much an exact fit here. And then I add one more term. It should only get better than it was, I think. Yeah, this is worse than it was, right? Yeah. I think it's worse here. This is worse than it was, I think. This is definitely worse. Definitely. And here yeah. It feels, it's not better than it was. And here does go up. Well, before it was just diving down, but not in a better way. And now here we have a big deviation. It looks like the extra term is wrong. So this is really, really wrong. This is wrong. It's the same as this one. So yeah, I think this must already be wrong. Which is hard to believe unless everything is wrong, because this is just a nice table here. How can it be wrong? Okay, so let's try something desperate. Adding a lot more terms. Well, that's definitely not, I don't believe it, but you never know. No, clearly not. Now it's like ding, wang, all over the place. More terms is not a solution. No. Ten should already be way enough. Yeah, I guess there is nothing else to do than to comment this out and add manually the next term and then compare it with this formula. You could do it in reverse, but I think I'm just going straight from the big formulas again. So we're talking here about, doesn't want to scroll because it's on insert. 1, 2, 3, 4, 5. That's u to the power of 5, 1/5 times the square root of d0 times bracket open g5 times u to the power of 5. This is what it should be. And I'm just going to type that in without any regards for patterns. Maybe I should type it like literally in everything, just to see if it gets better. Not even doing reusing stuff. It's a lot already. No, I don't want to do this. Okay, let's not do that then. Minus d3 divided by 4. So the underscore here means that it's already divided by d0. Yeah. So now we have d3 divided by d0 and divided by 4. And then this thing here, really, we should have that. Times, and that is. This one, right? Well, it's this thing, etc., but it belongs to 2, I think, G2. Yeah, peeking ahead, but also see it here. G3 is multiplied with, sorry, D3 is multiplied by G1 here. It has to be G2, and that's what I found. So okay, let's go with G2. Which is equal to this one, which means D2 divided by D0. Yeah, I already see it there, plus one other term. So this is correct, that would be this. Minus, not my, minus. 1.5 times D2 underscore. That's 2 divided by 3 times D2 divided by D0 times this thing. And it's just a little bit bigger than that one, but not super big. So unless I'm a complete idiot, it has to be G1 higher, G4. And, well, definitely not. G3 then. This thing is this thing, yeah? 3, D3, minus d1 square divided by 42 plus divided by plus 3, so that's exactly the same thing. So that would be g3, which makes sense because just before we had g2. Then we get this term here. So that would be plus d1 underscore half times d4 underscore, both divided by d2, d0 I mean, so yeah, that's the whole thing. Minus, and then we get 7 times, maybe let's do this paranoid, 7 divided by 8 times d1 divided by d0 times this thing, and that thing is equal to this thing because it is, which is g4. So manually, straight from the formula. If this doesn't work, then Mathematica is wrong, which is pretty unlikely. Yeah, okay. Yeah. It didn't. Oh yeah. Definitely. It's better. Better. It's better than without that term. Before I already got infinite deviations. Like if you did this and it would go like that, right? Doesn't do that anymore. So this is not the same as what I was adding in the loop, apparently. It quite obviously isn't, because I'm starting with G1. There's not even a G1 in here. Huh? Okay, what the fuck, dude? This was this one. Let me think. That is definitely 7/8. Yeah, it's this one. That is G5. 1, 2, 3, 4, 5. I guess that's G1. That's wrong. Did they shift them? Is this G5? No, that's 0 times G2. It's also not. Minus D3 divided by 4. That one. Minus D3 divided by 4 times G2. That's this term. Minus 1.5. No. Don't see that back here, huh? 2 divided by 3 is something else than this. So my whole table is wrong. What the hell? That is pretty sucky. Divided by 8 times d0. This one is what? It is. This one is correct. The g3 is 2/3. I have 3. It must be 3 divided by 2 maybe instead of 2 divided by 3. Oh man. Yeah, I'm pretty convinced that everything is correct except then maybe the integer values here. So we have d4 times, well, d4 here and d3 here and d2 here and d1 here, right? And the g values are also correct. Just these integers. And if that is the case, then I should be able to rather quickly fix my table. I'm going to rewrite this. It's kind of weird though that, or maybe that's this discrepancy here, or how do you call that? Well, that was weird. But g4 was correct, wasn't it? So yeah, that stays then anyway. Let me manually check that one. Anyway, we'll just, in the end, we'll just have to do everything over, I guess. Okay, I want to do over the this one. Or did I already look at that one? I don't know. But then we're going to assume that the pattern of G1, G2, G3 is just correct. So I think it shouldn't be that hard. So here I have D1 times G3. So that is this D1, and this is done D3, whatever. And then we have 5, 6, minus 5, 6. That's this one. And then we have G2, which is then probably the first one, which is then minus a half. Yep. And then we have G1, which is then, yeah, that's harder to check, but it's the one that is multiplied by D3, so that must be that one. And then half, well, difficult. It depends on G1, so it's just hard to see. Did I already check that or not? No, this is G1, I know that. The whole thing is G1? No. No, this is G2. G1 is this one. So D1 is D1 is D1 divided by 2D0. Yep. So D1. Project. So it becomes D3 D1 divided by 4 D0 squared. Yeah, that's what it says here. And here I have 2 times D4 divided by D0. It's just that two. Okay, that's definitely correct. Right, so let's do the next one then. This is 6, which is this whole thing here. We just start at the back, so that would be. Oh, why would they start at the back? I start at the back. Minus 9 tenth times D1 divided by D0 times G5. And then in front of that we have 3/4 times D2 divided by D4. I'm going to assume that this is G4. And in front of that we have minus D3 minus a half times D3 times G something. That was a minus. This is 1 divided by 2, I guess. No. This should be D3. Yeah, must be D3, right? Now, let's see if that one also improves things a little bit. Not super fast. Oh, it's actually making it really bad. I think this made it worse than it was. Yeah, oh yeah, look at that. Nope. This one's also not really that you say, but okay, it only got worse, so I don't. Man, what the fuck? This really suddenly looks really bad as well. Can't do this, I have to automate it. Which means I have this file here. Let's go. Downloads. Start up the notebook. And that contains everything in some way. So we could write a program that parses this and then automate everything. Then at least I cannot make a mistake. But yeah, you hardly want to go that way, right? That is h0 square root of d0 plus fraction box. Okay, this is the next term. Fraction box probably ends there. Jump plus next term. Like that one thing. What is that? Row box. Yeah, I would say that after a plus, let's separate them completely because square root of this must be the first one then, and then we get the next one and the next one. And I just know that it is not plus in the middle because I can jump from this thing to there. So yeah, that must be the next one, right? And here we can jump to that one, so this must be the next one. And then it gets larger and larger. This row box goes to there. And this row box goes to there. And by now, fractions, oh, 7, yeah, there is 1/7, I mean that's then G7 follows. And how far do I want to go? One, two, three, 4, 5, 6, 7 is already the next one. Could help, but probably I want to see more. I just want to see 10 of them, I think. Which is quite a lot. I could split them up, but I feel coming that I have to write a C++ program to parse this. Okay, split it up anyway. So this is 1/8. And then we get 1/9. And then we get 1/10. And that should be enough, including the 1/10. Might not even have more. This looks weird. I don't know. Different than these things. Let's just delete everything below this, because that is term number 10. So delete that. And that means that if I jump from here to there, yep. Now, fraction box is super clear. That is just something comma something, and that means the first thing divided by the second thing. Square root also super clear. Just square root of the thing, and I only have square roots of d0. And then we have a row box, superscript box. Well, that's to apply power. And I don't think these things are larger than... yeah, I only take... I think powers of 2, unless it's u itself. Let's say search for that, followed by anything but a comma, followed by a comma, followed by quotes, followed by anything but 2. Yep, just u, right? U to the power 4, u to the power 7, u to the power 10. The others must be cut in half at the end of the line. But okay, anyway. How to interpret a row box? So multiplication. I think it's just something times something, etc. I have a row box with parentheses open. Minus fraction. But a row box is like parentheses, it seems. Okay. Now let's write a program to analyze it, because it's almost bedtime. Shit. vi parse in b dot cpp. Open the file, standard input, input f-stream, file, file.open. Standard string line, maybe? I don't know. I'm just guessing here to avoid having to ask ChatGPT. Bah, it compiles. No, that looks interesting. I don't know what happened, but doesn't look like lines to me. I think it reads still spaces. It's not what we want. We want to read actually a whole line. So get line, I think it is, right? Like get. Dude, I don't know. I don't know that. To read a file in C++, line by line. Get line. Okay, yeah, stop. We have it. So it was get line, but like that, standard get line. I only asked ChatGPT 10 times this. Go. That. Bloop. No, yeah, that looks more like lines. Now it also passes spaces. And then I want to parse these lines. Oh no. Man. I'm not even sure what I want. Probably should just, you know, read everything into memory as objects. Yeah. Definitely. Okay. So it's unfortunately it's too late to actually start this. Maybe I should stop and then start afresh with the program tomorrow. Or maybe it doesn't really matter. I don't know. Symbols have a name. Standard string name. Let's call it a power. Power is always a symbol. I'm pretty sure of that. So I can power is just, yeah. I can't do something between brackets and then do it to power because I don't need it. It's just never done. In fact, maybe I don't even want or need the power. It's always a square, except when it is not square, but it is u to the power something. Could do a different type even for that. Yeah, it's absolutely horrible, but this is a square. But okay, we use a symbol. And then I don't need anything else because it is a square. And then I have a power of u, which is then always u, so I don't need a symbol. Just int the exponent or the power. Then of course we have a fraction. The fraction can contain a lot of stuff though. So I guess everything here has to be derived from something. Expression, of course. So you have struct expression. And then all these things are expressions. And then you have a fraction. And a fraction is the division between two expressions. So expression 1. Reference? Nah, pointers. Get that. Enumerator. Denominator. Now you feel it coming, that this is going to be a virtual base class plus pointers. So yeah, even if I don't make that mistake, the compiler is going to complain about it. So we need a virtual destructor here, even just to shut up the compiler. And then we have what are row boxes? Yeah. I think a row box is just a multiplication, because if it isn't, then there was a minus or a plus string. So you can have a row box of something, that's multiplication, or a row box of something space something, that's a multiplication. I'll just have to split those, I think. See, we do have multiplications. I don't think I ever multiply more than 2 terms. I'm looking at the big formulas here. So d1 times d3 we have, and we have, well, I have 1/5 times the square root of d times, yeah, okay. Just a few times maybe. So you could make a product. A product of, obviously, expressions. Yeah, product itself is also an expression. Fraction is an expression. Everything is an expression. Now, do we have more? I don't think so. Multiplication, division with a fraction, addition, subtraction, and I just put it in the sum with a negative sign in front of it. No, how would I do that? So sum, then I need a unary multiplication with minus 1 or something. Yeah, so a negation, as it were. So we can have a negation struct, which is an expression that puts a minus sign in front of another expression, which is think of a word. And the other thing, expression. Very good. We have everything, yes? So the whole shebang is going to be a sum, because we begin with let's just make a sum. Still have to parse the line. Okay, let me see. Notebooks, I'm gonna delete stuff, I think. Just want to start here. Interpretation box, my ass. Log, blah, 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 blah. But all of that is then a sum. So maybe I should have left a row box. Row box. Row boxes, to all row boxes start with is there a row box that starts with something else than an opening brace? No. Okay. So that's kind of a double thing then. Oh, I still have to close it. Row boxes are closed like probably like that. Blink, blink. Yeah, I think so. Yeah, totally. Absolutely. As you can see here. So let's be nice and close the thing. That's that row box. Very good. And we know that it is a sum because there is a plus here. But then I don't know that it is a sum at the moment that I'm reading this. So we need something that temporarily stores this until we see that it is a plus, and then only then I can put it in the sum. Darkin, I'm not doing machine learning right now. I hardly knew anything. Yeah, I didn't study it or anything. I basically knew about machine learning the same as what you can pick up from YouTube or something like that. Okay. Going to assume that the row box after the first element, after the first comma, always has a plus or a space. or it starts with the minus. We also have division, but okay, an operator anyway. Oh, I need a division then. Yeah, oh, we also have a parenthesis in it. The most annoying thing of this is that I wrote so much code to do certain things, including this. But then when I need it, I don't use it. I'm just starting from scratch, which is, the reason is that what I wrote is so powerful that it probably takes an hour to set up. There's a, I mean, yeah, it's, if you need it, then it's worth the time. But if you do something simple like this, then maybe it's not. But I have parsers that would be, but you would just parse this. But they are more written for high volume parsing of socket input, so networking stuff. And then this would be a protocol. That would work something like you get a piece and then it figures out high speed, looking for characters to know if there is something that can be parsed. And if that is the case, then that piece is parsed to, yeah, I don't know, it's really object oriented and fast. And I'm struggling to do the same thing more or less. It's annoying. So to think that maybe I should treat Roblox just as Roblox without specifying yet what it exactly is doing. How many arguments does a Roblox have? Can it have more than 3 arguments? Could start with parsing and then find out how many arguments a Roblox has. I think I'll do that. So I'm going to make a Roblox. Which doesn't know what it is yet. Yep. Okay. Now we need to have a lines, but it might be incomplete. Basically, well, no, it's not incomplete. It's always it lines never cut off in the middle of a keyword. So I can decode this. I think the best thing is still to use a state machine. And the state machine then should be able to get the next token. So I have to tokenize the input. Problem is still they end on commas or bracket open, it seems. Might be a coincidence. Does it never close end on a... Does it never start with a comma? That would be a good one. Comma in the beginning, nope. Does it ever end on anything but a comma or... Yeah, my own line here. And the beginning. That's it. So yeah, it's either a comma or a square bracket open that the line ends on. Which I'm also pretty much convinced that it never cuts a string into. Right, because if that would mean that it would stop in the middle of a string, and I don't have square brackets or commas in the middle of my strings. So another shortcut there. We can always parse strings. You can always parse tokens. There's not much else left, really. I begin with a row box, but maybe I should not end on a... Yeah, that's better. Now we end on a comma. That is allowed. At least empty lines I will allow. And then here we end on, yeah, but that's the end, so, okay. Yeah, I'll add special code if needed. I want to clean my keyboard, but I think I'll first leave this. What the hell is this, man? I'm very amazed that I'm not seeing a lot of characters on the screen. But who am I to complain? Oh. Not aware of you. So, what is the next step? Caps lock. Does string view not have its own header? I doubt that this is the right one. Standard string view. It is string view. Never saw an underscore in a header before. Normally they don't do that. Well, if we are here, then we have to feed the line, I think, to the current expression. So let's add an expression pointer. Current. And then if there is a current expression, then pass the line on to that expression. And yeah, no. No. I think I should go to bed. I'll continue this tomorrow. It's not easy actually. No, maybe you can do this. Current is current process law. And there is no current expression, which would be the case the first time, then we should be processing a row box. Right, so I want to eat a token. I'm getting the feeling I should turn the whole line into a structure or class. We need a head or a head and a tail or not? I can just make a copy of the iterator now. So auto current is head. Return current or something, and then here advanced head. If there is no such thing, then what? Could throw an exception. I don't like exceptions that much. No, I just have to make an enum, I think, of all the possible tokens that exist. And then return that. So we have a non-left keyword bracket decode immediately if it is bracket open or not. Bracket open or close. No, one here. Bracket close. String. Comma. Do we have other stuff? Got it already, man. Braces, open and close. That's about it. Comma is a bit bullshit, right? Well, then again, those four as well. Maybe we should just single character or something. This is just a tokenizer. It's a special character. What kind of character it is? Anything that is not the above. Yeah, what do we all have, man? Square root box, fraction box, square root box, superscript box. Distance. Standard distance. Oh, I thought it was a way newer. It's already C plus 17. Right. Yeah. I'll start with copying it, I guess. So it repeated this, but I'll just paste its new code there. And then repeat. The set line begin. Very good. Token. Next token send a string out. Let's skip that. And that should be the end of the file. Very good. So we have one function to check. Next token string view out. Skip any white spaces while head is unequal line end and is space head plus plus head. Oh, unequal. Yeah. Okay. If head equals line end, return none. Very good. Auto sort is head. Check for string token. It's head equals quote plus plus. Skip the opening quote. While head is unequal end, line end. And head is unequal quote plus plus head. If head is unequal line end, what was head? Include the closing quote. Out is standard string view start comma distance start comma head. I believe that. Then string. Okay. Check for the keyword token. If is alpha head, while head is unequal and standard is all num. Very good. Other, it's not one of the specific keywords. Treat it as other. Okay. Not really, but yeah, let's just assert here. But I don't like this happening. So if it's an alpha, then it eats underscores and everything. Yeah, okay. Yeah, that should be 1, I think. I've got a lot of headers. Cannot convert const iterator to, I don't know, probably normal iterator. Const make. Still a problem with it. Cannot convert const iterator to basic string view const iterator. Oh, yeah. Indeed. How do you get a string view const iterated from a string? Like that, apparently. Process. Expression has no process. Yeah, I'm going to bed. It's getting too late. That must return an expression pointer. Implement, please. Tje. Nothing. Not even an assert. Okay, open the file. Read one line at a time. Create a line object, which just stores a string view and a pointer to it, to the beginning. Okay, wait a minute. Yeah. And then we call process with that line, which passes it to the current process, which does not exist. So we get here, which doesn't do anything, and then return false, and then break. Okay, that's why. I should do something here. Yeah, because the file begins with rowbox. So the first token that we get should be a keyword. Moreover, it should be a rowbox. So we can go here again and then assert that it is a rowbox. Let's call type token type. Okay. Yeah, a token should be what? String view. Okay. Not const line is this. The line is const, and next token is apparently not sure why. Should it be const? Can this be const? It cannot be const because it's moving head and everything. Well, and everything is moving head. Okay, so this is not const. Let's not make it const. Which means that line cannot be const. Why can line not be const? Oh, right. I'm an idiot. By reference? Really? Nah, might as well absorb the whole thing. Not even going to do that. I could just that little line there. Well, not even this is necessary. So I'm passing a standard string, and process wants to have a line. Well, it is by value, whatever. Insane laughter. And then just creates a line from the string. Okay. Okay. And it did abort. Now why would that be? It's not a keyword. I guess I have no clue, so we have to debug it in debugger. Dot out, run, break main, run, next. Open the file, read the line, print the line, start with row box, step, construct the line, warning, no such file or directory. What are you doing there then anyway? Man, who thought of this? There is no current, obviously. Next. Next token. Okay. Print line. Oh. Up. Print line. Row box. Line underscores row box. And that is also pointing to the R of row box. So far so good. And now we are here. Still. What? Next. While head is unequal line end. Definitely should be unequal line end, right? Points to row box. And is space head, not a space. So no skipping of spaces. Line end? Nope. Start is head. Print start. Totally row box. If head is a quote, nope. Is alpha, yes, this is alpha. Okay. While head is unequal and n is what is it going to do? Oh, it's going to read a whole row box. Okay. So this is the R, skipping to the O, skipping to the W, skipping to the B, to the O, to the X, beyond the row box. That means that now it's not an underscore or an alphanumeric, so this should fail, and it fails. Print out row box. If out equals row box, yes, return keyword. Dude, just works. Assert type is keyword. Print type keyword. Next. Print token. Row box. Assert token equals row box. So it did work. Print current. Current is still 0. That's why it crashes. Now it ends again and the expression is still 0. So yeah. Okay. Stupid. Lots of debugging, and the only thing we've got is to create an expression. So I'm going to do current is new row box. Let it leak. I don't care. So we make a new row box, and then next time we're going to assert here because yeah. Does not assert. How the hell does it not assert? So this now returns true because, oh, yeah, and then we break. So it should do the opposite actually. Equals null pointer. So then it returns false, which means that we don't break, which means that we read the next line, which is bullshit because there's still more to decode. We should only return here when we processed everything. Well, this thing probably should only return when it processed everything. So the problem is that here I should return calling that thing again. Nah, can't do that. Don't want to reconstruct my line. Just gonna do this. Not current, that is the first time. We decode one token, which must be row box, and then we create a row box, and then we call process on row box with the rest of the line, and then we assert. Yep. Oh, wait, assertion. Yeah, row box. There it is. Let's decode the row box. So what the row box wants is, when it begins, is to get next token. Wait. Token. Next token. Assert type equals other. Totally. Assert token equals can't do that. Assert false. You gotta be kidding me. Well, it's pointing to that thing. Okay, can't do that. No problem. I'll just won't do it. Compared to that then. 2, 3, plus. And still. Line. Why is my line const again? Oh, again. Oh, shit. Well, that's easy to solve. Just a file-wide line const should not be const. And we assert at the right place, right? Yes. Okay. So now we are at the opening brace, or actually we already processed that one. It is good. I guess I should do a skip white space now, or, well, we don't have white space, right? I try to skip white space when there is never white space. There's white space at the end of the line though. The new line character, although you probably don't get that. I don't think if you do get line that you get a new line character. So even that should not be necessary. For the rest, there's no spaces except for spaces in the string. Yep, no, the next token should simply be opening thingy. Yep. Next token. Insert. Press. And now it gets more exciting. Type X token, and now it can be a lot of things. I'm going to bed, seriously. Now it's 1 AM, and this is also not good. It's possible that this one returns none. And there is nothing left. Guess if that is the case, then I just should return this. But that means that we are going to enter again at the top. So this whole thing now must be a state machine. Yeah, you don't know that. It's more like... Fuck this. Okay, I'm going to bed.